Okay, so now before going over the inclined plane problem, I wanted to just go over something called the components of a force when there is a block or any mass on an inclined plane. So I think you already know, but I thought we'll just go over it. So think this is an inclined plane, this one, and then we have the block here, right? So what are the forces acting on that? So the forces, one you can think of as the force of gravity, right? And then in this direction you'll have the force of friction. It could be static friction or kinetic friction, like we did in the last problem. Static friction is when we don't have any coefficient, but when we are given a coefficient and when it is sliding down, we'll call it a kinetic friction. And then we have the push that is getting exerted on this block from this inclined plane. We call this normal. So always one thing to remember is the normal force is perpendicular to the surface, right? It's always perpendicular. So the other thing here is, here the inclination is at some angle, we'll call it theta or theta. So normally what we have been doing is, like for example in the previous problem with the pulley, the two blocks hanging, or the other one on a surface with the pulley, another block hanging down and stuff. What direction did we have the forces in? It was mostly downward, and then upward tension, right? Or it was like friction was in the horizontal direction, I mean the tension, and in this direction it was the friction, F1. So it was, we dealt with mostly x and y axis, right? Now we have something which is inclined. So we will have to tilt our axis to match this. So I'm just going to draw here, like it will be something like this. It's not x and y exactly now. It's more like parallel to the inclined plane, and this will be perpendicular to the inclined plane. So as you may know, this is the symbol for perpendicular and this is the symbol for parallel, right? Parallel symbol and perpendicular symbol. So what happens in our case now? FG is, we have FG is in the vertical direction, and F of F friction is in the parallel direction, and Fn the normal force is in the perpendicular direction. So those are the three forces. And since we decided that we will calculate the component of the forces, basically what does a component of a force means is, according to my understanding, is to break down a force into two different directions. Okay, to two or whatever the depending on the directions. In our case it's, I would say, two directions. So we will, since we are dealing with an inclined plane now, like this force which is parallel and perpendicular, we'll consider that as like our regular forces, and anything else in a different direction, like now example this is in the vertical, like downward direction, which is neither parallel nor perpendicular, then we will have to come up with forces of this gravitational, the force of gravity, which is parallel to the inclined plane and perpendicular to the inclined plane. So to just draw it with a dotted line, if you want to extend this and this, you can extend this for your reference. So basically this will be F parallel, because this line is parallel to the inclined plane and this is vertical. So this force is, Don't worry about the direction, I am just drawing it. This is FG perpendicular, and this is, I call it FG parallel. FG parallel. This is FG into total, the regular one. But when we break it down into components, we have FG parallel, which is this, parallel to the inclined plane. When we say parallel and perpendicular, it is reference in reference with the inclined plane. And this is perpendicular to the inclined plane. Now we have to calculate how do we get this in terms of theta. Okay. So as you may already know from your calculus AB or trigonometry classes, that sine theta is equal to opposite side over hypotenuse, and cos theta is adjacent side over hypotenuse, right? And tan theta is opposite over adjacent, which is nothing but sine theta over cos theta. We're not using this right now, but just as reference. Sine and cos is what we will be using. We need to see if any of the angles in this triangle that we are getting, if we can get theta as the angle, right? So now since this is perpendicular, that means this entire angle is 90. So if you see this triangle now, this point to this, in this triangle, you see this is 90, this is theta. So what happens to this angle? We can figure out this one. So let's call it theta 2, and we'll call this theta 3. And you can notice one more thing is this one, this is parallel and this is vertical, right? I mean, this is not parallel. What I meant is like this surface and these two are perpendicular because the force of gravity is vertical and we have this horizontal axis, right? So this is 90. So as you know, in a triangle 180 degree, so theta plus 90 plus theta 3 is 180. So if you want to figure out what is theta 3, you can say it is 180 minus 90 minus theta. So theta 3 is 90 minus theta, right? If you want to figure out what is theta 2, like we already discussed that this angle is 90 degrees. So theta 2 is 90 minus theta 3, and we know theta 3 in terms of theta. So theta 2 can also be written as 90 minus theta, which we will be substituting here, which is 90 and negativity cancels, minus theta. So theta 2 is theta. So this is also theta. So now with this as a reference, the theta angle, what is FG parallel in terms of sine and cos, with this being the hypotenuse and this is the opposite side, right, to this. So FG parallel, if you want to write, opposite is, how do you write it? FG parallel over FG. FG is the hypotenuse, FG is the opposite side, right, is equal to sine theta. Similarly, FG perpendicular is this one, the side which is adjacent, over the hypotenuse, which is FG, you have cos theta. Make sense? So if you consider this triangle, this theta 2 we derived, it's equal to theta, right, as it's the same as this. you could arrive at this in different ways, like you can compare as parallels, and you can say interior opposite angles, and external. You can arrive at any with any theorems or like anyhow, but once after that we know that this angle is theta. So now we know that we extended this. We are basically trying to get the components we are trying to break this down, this force Fg, into two different components which are either parallel to this inclined plane and which are perpendicular. So Fg is the force of gravity, and then Fg parallel is one component and Fg perpendicular. So to calculate Fg parallel and Fg perpendicular, we are trying to take the help of this angle theta and trying to get it through this trigonometric equation. So sine theta is opposite over hypotenuse. This is theta. Opposite is Fg parallel and hypotenuse is Fg. For perpendicular, it's the cos theta is adjacent Fg perpendicular over Fg. That's your cos theta. So now if you want Fg parallel, it will be Fg times sine theta. This is one component. And Fg perpendicular is Fg times cos theta. Make sense? So once we have these two ready, then we will be able to deal with any inclined plane. So does this make sense? I hope it's all visible. Sorry with my I think I'll have to tilt it a little bit. Okay. Okay. No, I think we have. So to go over quickly once again. So we have an inclined plane. The forces acting on that are the static friction force and the normal force and the force of gravity. So normally when we deal with regular forces, it's either vertical or horizontal, like in x and y directions. But on an inclined plane, which is inclined at some angle to the horizontal surface, so then we will have to break the vertical or the horizontal. If we had the horizontal, we have to break it down into the components which matches with the inclined planes parallel, which is parallel and perpendicular to the inclined plane. So in our case, force of gravity is vertical, so we are trying to break it down into the vertical, the perpendicular and parallel forces, right? So for that, here, so for that we are taking the help of theta and we are doing some calculations and figuring it out how to get these two components. Okay.